Today we're looking at lesson 6.5 for geometry. This is on rhombi and squares. Rhombi is the plural of rhombus, so more than one rhombus. There are several theorems that are brought up in this section. You have two theorems related to the diagonals of rhombus, and if it's a parallelogram and it's a rhombus, then its diagonals are going to be perpendicular. And if it's a parallelogram that's a rhombus, then each diagonal bisects a pair of opposite angles. A few more theorems. Here's a good comparison of the difference between rectangles, squares, and rhombi. Notice that squares share both rectangles' qualities and rhombi's qualities. And then we have more theorems here. This is if we have rhombi and squares. So if you have the diagonals of a parallelogram that are perpendicular, then the parallelogram is a rhombus. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram's a rhombus. So these are basically converses of the ones that we just did. Then if you have one pair of consecutive sides of a parallelogram that are congruent, the parallelogram is a rhombus. And if a quadrilateral is both a rectangle and a rhombus, then it is a square. So with this information, we're going to look at finding measures. So the first one, if FK is 5 and FG is 13, we know that the diagonals are going to form perpendicular lines. So this would be technically a right triangle, even though it doesn't look like it. And in order to find the third side, GK, we would need to use the Pythagorean theorem. And GK is going to be the same as JK, since we have diagonals bisecting each other. So we have a leg, 5 squared, plus we don't know, and then the hypotenuse, 13 squared. So we're going to solve for B. Gives me 169, and then I'm going to subtract 25. To get 144, so B squared is 144. That makes the square root of B squared 12, or GK is 12, so we can say that JK is also 12. Then we have angle JFK. That's going to be here. And angle KFG, that's the other side. We know that the diagonals bisect them, so it makes them equal. So if we're going to find y here, we're going to put 6y plus 7 equals 9y minus 5. And solve for y that way. So y would be 4. The next one, we're going to do a proof. So it gives us that SQ is the perpendicular bisector of PR, making these perpendicular. PR is the perpendicular bisector of SQ, which basically just does, again, what I showed you. And then RMS is isosceles, so that makes these two sides equal. We need to prove that the entire figure PQRS is a square. So we're going to start with the givens. Then we could say something about the diagonals bisecting each other, because we know that they're already perpendicular bisectors. So we can say that PQRS is a parallelogram, because the diagonals bisect each other. That's 6.11. And then we have, if the diagonals are congruent, we know that PQRS is a rectangle. And we know that they're congruent because we know that two sides here are labeled as equal. So if we just substitute another side and another side for it, then we can say that they're all equal because they're bisectors, so they make each part of the diagonals equal. So we can say, instead of RM being equal to MS, we could say, let's say MS is equal to MP, as well as MR is equal to MQ, and then that way we know that all of them are equal. So the diagonals are congruent. That's 6.14, and that makes it a rectangle. So we now know that it's a parallelogram and a rectangle. We know that the diagonals are perpendicular because it told us. So that makes it a rhombus. And then since it's a rectangle and a rhombus, we can use 6.2 or 20 because it's both a rectangle and a rhombus to say it's a square. And then we'd have our proof. The next one, Kathy's designing a quilt with blocks like the one shown, so this picture here. We need to think about if she marks the diagonals of each yellow piece and determines, that each pair of diagonals is perpendicular, can she conclude that each yellow piece is a rhombus? This is a little bit of a trick question because, yes, if the diagonals are perpendicular, then it's a rhombus, but the figure needs to be a parallelogram first. So if she just marks that the diagonals are perpendicular, she technically can't say that it's a rhombus because she needs to prove that first they're a parallelogram. The next one, with the same figure, if you have all four angles of the green piece having the same measure, and the bottom and left sides have the same measure, can she conclude that the green piece is a square? So this and this, then we know that all the angles are 90. Can we say that it's a square? I would say yes, because if you have all four angles being the same measure, you know that they have to be equal to 360. So 360 divided by 4 is 90. So that makes each angle 90. And then opposite angles are congruent, so that makes each, or makes the figure parallelogram. Always have to make sure that it's a parallelogram first before we figure out it's a rhombi or a square. And then, if each of the measures of the angles are 90, then it has four right angles, so it's a rectangle. And so now we have that it's a parallelogram and a rectangle. And then also there's a theorem 6.19 where it says consecutive sides are congruent. It's a square. So it also said that the consecutive sides are congruent. So it's a square. And then the last one, we're going to determine whether this figure is a rhombus, a rectangle, or a square, or a combination of some or all, and then we're going to explain. So I would have a piece of graph paper here, but for the purposes of here, I'm going to draw my graph. Get a little bit bigger. So my first point is J at 5, 0. Whoops, that's actually not right. That's 0, 5. It's going to be here. So that's J. Then we have 8, negative 11. That's going to be K, and then we have negative 3, negative 14. L, and M, negative 6, negative 3. So we have our figure. Now, just because it might look like a parallelogram doesn't make it one. So we need to figure out, or just because it looks like a rhombus or a rectangle or a square doesn't make it one. It tells us that it is a parallelogram. So with that information, we need to figure out what can tell us that it's also a square, a rectangle, or a rhombus. I would use the distance formula to try to prove that consecutive sides of the parallelogram are congruent. So maybe JM and LM. So we're going to use the distance formula for them. So we have 5, 0, negative 6, negative 3. And LM is negative 3, negative 14, negative 6, negative 3. So if these are the same, then we can say that it's a rhombus. So we have the distance formula. Subtract our x's squared. Subtract our y's square. the square root of 130. Let's try that again for the second pair. And we get square root of 130 as well. So we can first say that since JM and LM are congruent, that it's a rhombus. Now we want to prove that it's a rectangle, because if we can say that both are proven, then we can say that it's also a square. So a rectangle, the diagonals are congruent based on theorem 6.14. So the diagonals being congruent, that would make Km having to be congruent to JL, so distance formula again. Km, 8, negative 11. And LJ is negative 3, negative 14, 5, 0. So we're going to use the distance formula again. So we're going to see if the other one gives us that. Square root of 260. And it also gives us that. So we've proven that it's a rectangle because the diagonals are congruent, a rhombus because consecutive sides are congruent. So we can say that if it's a rectangle and a rhombus, then it's also a square because of 6.20. So that would be your explanation. And that concludes lesson 6.5 on rhombi and squares.